describe what it means by period. Okay, what it means by period, group, or blocks. Okay, so based on your SPTF notation. Okay, and then after that, you need to be able to deduce where is this element inside your periodic table. Okay, according to the electronic configurations that you have learned before. So some of the terminology that you need to understand is listed out in the notes given. Okay, so first one is the outer shell. So that means if you look at the atomic structures, so let's say this one is your atom, is your nucleus. Inside nucleus, you contain neutron and also proton. And then after that, you got your shell, n equals to 1, n equals to 2, n equals to 3, and so on. So the outer shell, that means the outer layer. Outer shell over here. And also inner shell, which means the inner one. N equals to 2, n equals to 1. So that refers to your inner shell. So you need to recognize what it means by outer shell, or sometimes it will say outermost shell. That means yang paling luar sekali lah dekat sini. Okay, and it's already stated over here, the highest value of n. Okay, to remind yourself, n is the energy level or our principal quantum number. And then inner shell, those shell which has lower values of n. So inner shell normally it can be more than one shell. Maybe one shell, maybe two shell, but the outer shell is only one cell. Okay, with the highest value of n. And then after that, you also need to know what is the outer electron. So madam put a highlight over here with a double star to indicate outer electron and also valence electron. Two of this terminology means two different things. Sometimes they can be the same, sometimes they will be different. So let's look at the definitions here. Outer electrons means the electron in the outermost shell with the highest n value. Okay, but then for valence electrons are the electrons that involve in your chemical reactions, in bond formation or in bond breaking. Okay, it may be different from your outer electron. I hope everyone recognize what is a valence electron. Okay, so later on we will practice a little bit regarding to the valence electron and how to write the valence electronic configuration. Okay, so both of this highlighted that you need to pay attention in the later concept. Yeah. Okay, and the last one over here we have the inner electron. That means all the electron in your inner shell. Just now we have outer shell, inner shell. So inner electron is the electron, okay, located in the inner shell with a lower value of n. So inside periodic table, I think you're quite familiar with this, isn't it? Pernah study kan periodic table?
Pernah.
Yes.
Pernah kan, selalu tengok dan dalam kimia. Okay, so periodic table is what you need to study, okay, for this chapter 3. Okay, how is the group arranged? How is the period arranged? And then how does it related to your electronic configuration? Okay, so over here, periodic table, the elements are arranged in the order of increasing proton number. Okay, we are using the symbol Z over here. Okay, Z refer to your proton number. And sometimes it can call this proton number as your atomic mass. Some revision for your chapter 1, atomic mass. So let's say over here, if I given you a, not atomic mass, it's an atomic number. Right, so proton number are also called as the atomic number with a symbol of Z. Okay, sometimes it's also called as the nuclear charge. So dua benda ni madam nak awak catat dalam awak punya nota. Okay, atomic number or nuclear charge. So it's the same meaning when we are talking about proton number. Okay, or number of proton with the same symbol Z. So if you look at this periodic table, for hydrogen with a proton number 1, helium proton number 2, lithium 3, beryllium 4, boron 5, carbon 6, and so on. So if you look at the periodic table, every number actually you can arrange it by yourself. Okay, and then normally I will encourage my students to memorize. Memorize berapa? 20 elemen yang pertama. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. Sampailah kalsium. Yang ini awak hafal. Tapi sebab tak ada exam kan. So, you boleh rujuk lah kalau nak buat assignment ke apa. Soalan boleh rujuk lah. Okay. But it will be better if you can memorize until element 20 lah over here. The last one will be your calcium. Okay. And then over here, if you look at your periodic table, the period, okay, is your horizontal row. Okay, so in this case, if you're looking at this way, this is your horizontal row. Period 1, period 2, period 3, and so on until period 7. Okay, and this period, up until 7, it will be indicated by the principal quantum number n. So elements of the same period will have the same energy level. Okay, so to remind yourself also, principal quantum number n is the same terminology as energy level, or sometimes we can call it as shell. So bila Madam mention shell ke, energy level ke, principal quantum number, semua kita boleh guna simbol n. Everyone's alright?
Yes.
Okay. So period, we're starting from 1. So that means if you take it from period 1, that means you only got one shell. Dekat sini Madam tulis Kalau period 1, okay, n ada satu saja. So n energy level, you only got one shell. If come to period 2, that means you have two shell. You have two energy level. That means up until n equals to 2. If you come from the elements from period 3, that means your n will be up to n equals to 3. You have 3 shell or 3 energy level. So up until 7 over here, that means you have 7 shell or 7 energy level. So yang itu adalah untuk period. Whereas if we are talking about the group, it means the vertical column. Okay, so I'm using a different color. A vertical column is called the group. So we have group 1, group 2, group 3 until 12. Then group 13 until group 18. So semua ini kita panggil sebagai group. Okay, and then this vertical column, okay, elements from the same group will have the same number of valence electron. So contoh yang paling senang lah selalu awak pakai adalah sodium. Sodium, lithium, sodium, potassium, they all having one valence electron. So they are from the same group number 1. If we look at helium, neon, or argon, that means you have 8 valence electron beside helium lah. Helium only got 2 valence electron. So if let's say we take neon, argon, krypton, xenon, all of this have 8 valence electron, and it indicates they are from group 18. If you got 3 valence electron, for example, boron, aluminium, gallium, okay, they are from group 13. So please remember, horizontal for period, vertical for group. So also a little bit of revision for all of you. So far, any question for the first page over here? Anyone?
No, madam.
Tak ada Kita mulakan dengan yang senang dulu. Okay. So, we proceed to the next one. How are we going to link between the period, the group with our electronic configuration? So here is 3 things I want you to record down first. Okay, for period, it depends on the highest value of n. Catat dulu ketiga point ni. Tak ada dalam awak punya nota ya. Okay, you need to record down. To determine the period, first of all, you need to figure out, okay, what is the highest value of the n? Okay, and then after that, we need to determine, let's say we want to determine the group. Okay, so for group, it depends on your number of valence electron. So from here, also, you need to understand, or you need to be able to find out what is the valence electronic configuration. So from here, it will help you to recognize the number of your valence electron. And then for the terms over here is the block. Now, how are we going to recognize the block? Okay, and it depends on where is your last electron located. So we are going to look at this one. Nah, dekat sini madam guna color lain lah, macam tak nampak kan purple color. Okay, so block last electron located. So for this one a little bit later, yeah. So let's look at another way of presenting your periodic table. So if you look at this table, okay, you look at the table over here. You can also refer to your notes that you have printed out, yeah. Okay. So let me see. Okay, so if we focus on group 1 over here, group 1 is actually your alkaline metal. So our valence electronic configuration will show as NS1. Okay, valence electron of 1 belongs to group 1. And then for group 2 is alkaline earth method. Okay, it will have the valence electronic configurations of NS2, which means you have 2 valence electrons. Okay, and then after that, let's look at group 13 first. Group 13, okay, you have the valence electronic configuration of NS2 and P1. So 3 valence electron belongs to group 13. Then group 14, NS2 and P2, this N value belongs to the period. So for example, if you've got the element from period 2, then this N value will be 2. If from period 3, then this N value will be 3. Okay, up until group 18. Okay, if you focus on the electronic configurations written over here, okay, 13 until group 18, NS2 and P1 until NS2 and P6. So from here is the main group. We will call the main group from group 1, group 2, group 13 until group 18. That is the main group. Okay, what is more special is about the transitions metal. So I want you to highlight over here the transitions metal starting from your group 3 until your group 12. Okay, is for transition metal. What is so special about this group? You can see the valence electronic configurations involve the S and N-1 d orbital. Okay, so for example, it involves 4s and 3d orbital. All right, so over here, let's look at group 3. Mana buka sikit Okay. So for example, for your group 3 elements, starting with the first group from your transitions element, you will have the 4s2 3d1. Okay, so it involves both of 4s and 3d orbitals. So even though, okay, the values of n is different. Value n dia tak sama, tapi kita akan ambil kedua-dua. Okay, sebab d orbital dia belum penuh lagi. Okay, so awak punya valence electron kita kena ambil kedua-dua. 4s dengan 3d sekali. Then the group 4, 4s2 3d2. So altogether 4 valence electron, but including the d orbital. Group 5, 4s2 3d3. So altogether 5 valence electron, including 4s and 3d. So do you get this idea for the valence electron? Is everyone all right with the valence electrons over here?
Yes, madam.
Yes, madam.
Alright. So madam nak tanya, kalau madam nak ambil valence electronic configurations from group 10, so what will it be for the valence electronic configuration? For S2 and
3d8.
3d8. Okay, so total up over here. So if you can see for S2 3d8, total valence electron will be 10 valence electron. Therefore, it is from your group 10. And then if from group 11, 4s2, 3d9. How about group 12? How many valence electron will you have?
4s2, 3d10.
Okay. Total valence electron? How about the total valence electron for group 12? 12 valence
12.
electron. Okay, so for S2, 3d10. Of course, you can also do it for 5s, 4d. Or maybe 6s, 5d. Or maybe 7s, 6d. So this is the special things about the transitions element. All right, so for the electronic configuration, of course, you need to keep on practicing writing according to the alphabet from 1s to s, 3s until you meet the 4s and 3d. Then only you will be able to recognize the valence electron. So over here, we back onto the points we have Madam asked you to write down just now. To determine the period, it depends on higher values on n. Block, it depends on last electron located. So this block will be on the next page. But first, you need to recognize the period and the group first. To determine group, you need to depend on the number of valence electron. So of course, besides memorizing your periodic table, you need to also learn how to recognize from the electronic configuration. Because sometimes they won't give you the element straight away. Dia mungkin bagi satu unknown. Okay, element X ada proton number 11. Okay, so identify where is the positions in the periodic table. So you need to understand how to obtain and interpret the information from the electronic configuration. So let's try the questions number 1 here. So let's say we have a sodium, proton number 11. So we write the electronic configurations first for sodium. We start for 1s2, and then you carry on.
2s2.
And
2p6.
2p6, and also
3s1.
3s1. Okay, so the question asks you to identify the group and period of the following species. So once you've written down the electronic configurations, so first of all, where is the period? Depends on the highest value of our n, which is period
3.
3. Okay, how about the group?
Group 1.
Group 1. Why group 1?
The last electron.
You only have one valence electron.
Valence electron. Yeah.
So as simple as that. Right. So next one, let's try the B for oxygen with 8 proton number. So we have 1s2, 2s,
2,
2p,
4.
4.
4. Okay. Make sure everyone know and already expert in writing out the electronic configuration. So 1s2, 2s2, 2p4. All the numbers adding up give you 8. So in this case, what is your period, the highest value of n?
2.
You have 2. And what is the group?
Group 4. People.
14.
14.
Group 40? Okay, so from the electronic configuration sudah betul kan? Boleh tak madam tahu valence electronic configuration ialah apa?
2 dengan 6 tu. 2 dengan 4 tu. Period.
Fokus dekat awak punya value n. Okay, dua subshell ini, 2s, 2p, dia ada n value yang sama. Okay, maksudnya dekat sini 2s2, 2p4 is your valence electronic configuration. Total berapa valence electron?
6.
6.
6 valence electron. So is it from group 6 or group 16?
Group
16.
16.
Group 16. Okay, because you have 2s2, 2p4. Awak tak masuk d orbital. So maksudnya awak tak ada transition element dan dia bukan daripada group 6. Tengok balik dekat sini Group 3 sampai 12 dia akan termasuk d orbital. Okay, d subshell d orbital. Tapi sekarang dekat awak punya electronic configuration hanya sampai 2p sahaja. Okay, so over here the only possible group for this oxygen is your group 16. Okay, so for those who are still lost direction in how to recognize the valence electron, please refer to the short video that Madam had posted earlier. Yeah, that one will be helpful for you to refer and identify valence electron. Of course, siapa yang sudah tengok dia akan faham untuk periodic table ni kita nak explain macam mana. Okay, kita try satu lagi example, which is your phosphorus. Okay, so for this one, phosphorus, we have a proton number 15. So 1s2, 2s2,
2p6,
2p6,
3s2,
and
3p, 3p3.
Okay, if you're adding up together, gives
Three.
you 15 total, yeah? Okay, so which one is your, madam tukar soalan valence electronic configuration ialah apa ya?
3s2 dengan 3p3.
Okay, 3s2 dengan 3p3. Yang ini sebab value n dia sama. So untuk ambil valence electron, kita akan rujuk ke dua-dua subshell. Okay, sebab dalam energy level sama 3s dengan 3p. Dia belum masuk 3D. So tak payah confuse dengan yang 4s 3D. Sebab belum masuk. Sebelum masuk 4s 3D, semua ikut yang simple. Level yang sama kita ambil semua. Level yang sama kita ambil semua. Okay, so in this case, 3s2, 3p3 altogether give you 5 valence electron. So first thing first, period is from group is from period
3.
3, highest value of n. And how about your group? Is it group 5 or group 15?
15.
15.
So do you hear about period and group?
Yes.
Yes, kita try satu lagi. Okay, Meda bagi soalan lain Let's say over here I have 70. Okay, I just give you element X with a proton number of 17. Okay, so for those who have already memorized the periodic table, then you can't just memorize, okay, this element is from which group, which period. You have to do the electronic configuration. So 1s2, 2s2, 2p6,
3s2,
3s2,
3p5.
3p5. So valence electronic configuration will be
3s2, 3p5.
total valence electron
7.
7. Okay, so where is the period?
3.
Period 3, highest value of n. And how about the group?
17.
Group
17.
17 because 7 electron. Okay, so maybe some of you will ask, Madam, how about if the elements come from block, come from the transitions element? Okay, let's just see this one. 21 proton number. So we have 1s2, 2s2, 2p6,
p6,
3s2,
3p6,
and then
4.
4s2.
4s2 and
3d,
3D1.
3d1. Okay, now tell me which one is the valence electronic configuration.
4s2, 3d1.
Okay, 4s2, 3d1. Okay, this is your valence electronic configuration. Total valence electron? 3 valence electron. So tell me about the highest value of n you can recognize from the electronic configuration.
4.
4.
Okay, so remember, always go for the highest n to determine the period. How about the group?
1.
Is it group 3 since it has 3 valence electrons?
No.
But is it from group 3 or group 13?
Group 3.
Group T.
Why group 3?
Transition element.
Transition element. Because you see something different. You see 4s and 3d. Some complication. Okay, therefore, when it comes to 4s, 3d, or maybe 5s, 4d, or maybe 6s, 5d, and so on, it means it's come from your transition element. And this is come from your group 3 until group 12. Okay, so we back to the periodic tables again. Buka yang ini. Okay, so if you recognize group 1, group 2, okay, group 13, group 18, so valence electron 1, 2, 3 until 8. For the transitions element, okay, starting from period 4, and when it involves the d orbital or the d subshell, so valence electron 3 until 12. So after you recognize the period and the group, the next thing is a new thing will be more helpful for you to determine the transition element will be the block. Okay, how to recognize the block. And let's just look at this. The block, all elements in the periodic table can be classified into 4 main blocks according to their valence electronic configuration. So over here, we have S block. Okay, for all of this is similar to what you learned for SPDF. This is also why you learn about SPDF according to the block. So we will have the S block, P block, D block, and also F block. So for S block over here, it involves only your group 1 and 2 element. Valence electron fill in S orbital. Okay, and the valence electronic configuration or the configurations of your valence electron will be NS1 and NS2. So looking at the examples given over here for sodium, okay, with 11 proton number. Hold on, yeah. Okay, sodium for 11 proton number, 1s2, 2s2, 2p6, and 3s1. So over here we see this, the last electron filling the electronic configuration is inside S subshell or S orbital. Therefore, this is belong to S group. So we look back at the last point madam given just now. You see, to determine the block, it depends on where is your last electron located. Memang kita isi electron dia ikut alpha principle, 1s, lepas 2s, 2p, and so on. So where is your last electron fall into? Then it will belong to that block. Okay, for calcium, 20 proton number, 1s2, 2s2, 2p6, 3s2, 3p6, and 4s2. So yang ini salah highlight. So you only highlight the 4s. Okay, so that means the last electron yang ke-20, okay, it enter your S subshell. Okay, subshell and orbital same meaning in this case. 4s orbital, okay, or 4s subshell. That means this belongs to S block. So we see where is your last electrons enter. So whenever you see the valence electronic configuration 1s1, NS1 or NS2, the N value can be any for 1 until 7. Okay, then it belongs to S group. Group 1 and group 2. If it's from P block, that means it is from group 13 until group 18. So the valence electron fill in S and P orbital. Please pay attention now. 2 subshell. Group 13, group 18, for P block, you have 2 subshell over here. S and also P orbitals. So the valence electronic configuration starting from NS2 and P1 up until NS2 np6. 3 valence electron until 8 valence electron. Okay, so this is 3 valence electron until 8 valence electron. But this belongs to the p group. And how are we going to see it? So if you look at the examples on the side, aluminium have 13 proton number, 13 electron. So 1s2, 2s2, 2p6. Then we have 3s2, 3p1. So over here, this is the valence electronic configuration. So as you can see over here, the total number of valence electron gives it the group, which is group 13. And the last electron fill in the p orbitals. Elektron yang last kali masuk dekat p orbital. Maksudnya dia adalah dari group block P. Okay, and then one more we see at the Pterylium over here. Okay, with 52 electrons. So from 1s2 up until 5s2, 5p4. So looking at this one, if you still remember from the last lesson, Madam ada mention, bila awak punya d orbital sudah penuh dan dia sudah masuk p orbital, maka kita move inside. So it will be easier for you to recognize which one is your valence electronic configuration. So we just kind of ignore the completely filled d orbital because now you have 5p already. Okay, so in this case, where it's entering S and P with the same n value, the highest n of 5, that means over here, the valence electronic configuration will be 5s2, 5p4. Total valence electron adalah 6. Okay, maka dia adalah daripada group 16. Okay, the last electron fill in the p orbital, therefore it is from block P. Is everyone all right until the p block?
Yes, madam.
Yes, madam.
Okay, madam.
Oh, slightly confusing. Ada sesiapa yang rasa confused tak?
So originally speaking, supposed to be 4, 6 and then afterwards 5s2, isn't it? So because of 5p is not fully filled, we just simply recycle it.
Merusak.
Sorry, Hazim, your questions? Okay, tak apa. Yang ni kan, I know this one is not according to outbound. Okay, but whenever you see the d orbital is fully filled, then we classify it as one shell. So the first n equal to 1, the first layer. Okay, the second layer, then the third layer. Since they're already completely filled, and you have entered another sub-level, you have entered another sub-shell. So the D sub-shell, we group it together. Okay, and then when it's entering the fourth sub-shell, so 4s, 4p, 4d, now the fourth level is completely filled as well. So we group it together. So it's no longer important. This one is all considered our inner shell or inner electrons already. So in chemistry, okay, or when we studying about the periodicity, okay, we are focusing more about the valence electron in the outer shell. So you need to know how to adjust the electronic configuration. Unless sekarang d orbital belum penuh. So kita susun ikut outbound. Tapi dekat sini sudah penuh kan, so kita rearrange balik untuk nampak kan dia punya valence electronic configuration. Okay, but this one is slightly complicated lah because it involves a lot of electron. Okay, so for block D, this is where it's come to complication. Okay, block D is starting from group 3 until group 12. Okay, and this is what we call as the transitions element. The valence electron fill in the ns and n-1d. 4s 3d, 5s 4d, and so on. So the valence electronic configurations, it comes from ns1, n-1d1 to ns2, n-1 d10. So from 3 valence electron until 12 valence electron. Okay, 3 valence electron until 12 valence electron, which involved in both of these subshell. So look at the electronic configuration for vanadium with 23 proton number. So 1s2, 2s2, 2p6, 3s2, 3p6. Then it enter 4s, 4s2, and 3d3. Okay, so in this case, we will take both of these subshell, the 4s and 3d, as our valence electronic configuration. And the number of valence electron total up will be 5. Okay, and because the last electron fill in your d orbitals, therefore it is coming from your d block. So bila awak sudah tahu dia daripada d block, so d block hanya ada kumpulan 3, group D3 from until group 12. Therefore, the only groups for this vanadium is come from group 5. It's not 15 anymore. So nak bezakan sama ada dia daripada group 5 atau group 15, awak tengok pada dia punya block. Kalau group 15, block P. Group 5 dan block D. The block is very important for you to classify. Sebab block kita hanya ada 4 saja. Manakala group ada 18. Okay, so this one is the shortcut for your electronic configuration whereby you're using the core configurations of argon. And then for the F block, that means the last electron will fill inside the F orbital. But we are not learning about that, so this is just an extra information for you. F block including lanthanide series from selenium to lithium and actinide series. So ini hanya satu rujukan saja. Soalan tak akan tanya untuk electronic configuration involving F block. Okay. So if you're looking at the periodic table as simplified for the four main group, this one is your X block. So group 1, group 2. So 1s come from period 1, 2s, period 2, 3s, period 3, and so on. Okay. And then for the exception for helium, because helium only got 2 valence electron. It only have 2 electron. Therefore, it belongs to 1s. Sebab last electron dia masuk dalam s orbital. So untuk helium adalah salah satu exception. And then for P block, okay, for P block, that means the last electron entering the P subshell, starting from 2p, 3p, 4p, 5p, and so on. So last electron entering the P subshell from group 30 until group 80. For your transition element, is starting from your group 3 until group 12. Okay, that means over here you involve the 4s3d, last electron entering the d block, d orbital, d subshell. And the period 5, we have 5s4d, last electron entering the d subshell. Period 6, we have 6s5d, last electron entering the 5d subshell, and so on. For the F block is what we call as the inner transition, also for your extra informations only. So it involves the last electron entering your F subshell. So if everyone alright in this case, ada soalan nak tanya untuk block?
So will you consider as P block even though it's only 1s?
For helium. Is it helium? Okay, never mind. Hazim, I think your mic having some problems because your madam can't hear you clearly. Okay. For 1s is exception lah because there is only 2 electron for helium, so we can't classify as the P block. But the last electron entering, 1s2, last electron entering your s orbital. So only for your helium, which come from group 80, belongs to S block. This is an exception. Yang lain semua ikut. block P, block D, block S, block F. So we repeat again. Okay, we repeat again the points over here, yeah, to help you to recognize in the periodic table where is this element located. Period, we look at the highest n value. Okay, for the block, it depends on where is your last electron entering. Okay, for a group, it depends on your number of valence electron. So normally the group will be a little bit problematic sebab ada yang ada masalah untuk tentukan valence electron. So over there, you need to pay attention and practice more for determining the group. Okay, so we try a little bit of exercises. Okay, question 2, determine the valence electron. Okay, so in this case, we have 4 things to identify. Valence electron, okay, the group, the period, the block of the following species. Okay. So, bagi masa sikit untuk awak buat, Madam sharekan Jamboard. Dan Madam sudah bagi nama siapa yang perlu buat soalan A, B, C, D. MS7 Maizatul ada? Maizatul Ayuni?
Ada, madam.
Ada ya? Okay. So, Maizatul Ayuni buat soalan A untuk potassium. Okay. MS8 Shazira ada?
Ada, madam.
Like aluminium, proton number 13. Mariam, MS9. Mariam, are you there? Mariam? Kejap ya, saya share dulu ya. The rest of you also try and then we check our answers together. Okay. Mariam for question 2C. And then for question 2D, MS32 Shariz. Shariz ada? Is Shariz there? Okay, Shariz buat dua soalan 2D. Terus tulis kat atas ni. Boleh type ataupun boleh tulis terus. Okay, so the rest of you try also for question 2 ABCD. Mariam ada tak Mariam? Mariam. What's your full name? Mariam.
Madam,
Mariam.
can you hear me?
Yes.
So I was asking about helium.
Uh-huh.
At the diagram before stated here, helium is in P block. Why is it? Even though it's 1s.
Okay, because helium is one of the exception. P block has already achieved the duplet, which is kind of similar to octet. Therefore, it is classified in group 18. Group 18, we know all is noble gas. Okay, all are noble gases. So they are having stable electronic configuration. So helium was put into the group 18. One is because the proton number, according to the proton number we arrange in the periodic table. Okay, second is because of the duplet, the complete electronic configuration. But in terms of the block, since the last electron entering your S subshell, then no choice, we have to classify as the S block.
All right, noted.
Okay. Right, is Mariam over here? Kalau tak ada, madam kena pilih orang lain. Ada siapa nak volunteer tak? MS9? No one's volunteering?
I can try.
You can try. Who are you?
I'm Nabil.
Nabil, okay. Nabil, thank you. Boleh cuba untuk ferrum, proton number of 26. And the rest of you try, and then madam give some time. And then later we'll check the answer together. So because of chapter 3.1 is some continual chapter from chapter 2.2 and 2.3, so madam will be a little bit faster for 3.1. Because electronic configuration, you are quite familiar. I have no idea familiar to which level lah, but you need to keep on practicing. Because electronic configuration still you are going to test it in the final year exam. Okay, but in chapter 3 it's only for assignment. But assignment also carry quite a lot of marks, altogether 15%.
I beg your pardon. Assignment. Which chapter?
Chapter 3.
This chapter.
Yes.
All right, that's interesting. How many of the percentage of it for our what does he
15%.
call?
15%.
GPA?
15%.
15?
Yes, 15%. Tapi madam akan bagi tahu dia punya cara nak bagi markah soalan dia bila madam dapat soalan nanti. Akan ada satu briefing lah untuk cara you jawab, cara hantar, cara nak dapat markah penuh. So normally assignment, our aims to have at least 95% or 100% full marks. Okay, because assignment you can check. Okay, first of all, assignment you can check. Second, you can refer to notes. You can search the information from internet. So there's no excuse that you get a lower mark for assignment. Okay, anything is available for you. Okay, so assignment you need to aim for at least 95% and above. Okay, tak ada sesiapa yang dapat below 95. Okay. So everything is contained inside the notes already. So what you need to do is just depends on what questions do you get, and then you interpret the questions, you answer the questions. So soalan nanti dalam minggu 8 mereka akan bagi. Okay. All right, so have you all done?
Yes.
Yang lain pun dah siap. Okay, let's just look at the first one. Maizatul, have you done that one?
Yes, madam. Ada kejap.
Okay, nanti Maizatul tengah typing Okay, Syazira dah. Mariam, yang ini Nabil dah. Charis tengah buat. Either typing or writing is both okay. Madam boleh faham lah. At least you try, and then we try to interact a little bit. Okay, so forward, when we are waiting for your friend, any questions you would like to ask about 3.1? We have already finished 3.1. 3.1 very short. We just want to identify the period block and also the group. But of course, it incorporate the previous knowledge from your chapter 2. Okay. Oh, Maizatul, you straight away tell madam what is your answer. So madam write it straight away over here. Can I know what is your valence electron for potassium?
7.
7. The group? You try to let madam know the answer, then we check together. What is the group?
17.
Period?
Period. Group 7. Period 5.
Group 7 or group 17?
17.
The block?
Block P.
block P. Right, my satu, like listen carefully and pay attention for the rest of you also. Bukan my satu seorang saja Okay, so let's say if you look at the potassium, proton number 90. So what is your first step? Write out the
Electronic configuration.
electronic configuration. Without the electronic configuration, you can't identify anything. Okay, so we have 1s2, 2s2, 2p6. Carry on. Carry on.
3s2,
3s2,
3p6.
3p6, 4s,
4s1.
1.
1. Okay, so in this case, how many valence electrons do we have?
1.
1.
1. Ayuh, tak nampak. Okay, so kita ada valence electron satu sahaja datang daripada 4s1. Ini adalah awak punya valence electronic configuration. Therefore, you have only one valence electron. Okay, since you only got one valence electron, where does it form? It is from group
Group 1.
Group 1.
Group 1. So if it having 4s1, the last electron entering s subshell or s orbital, which blocks does this come from?
S.
S block. Okay. And where is the period?
4.
Why 4?
4.
Highest energy level.
Highest value of n. So please practice your electronic configurations writing. So from there, practice 4 of this term. Valence electron determines the group. Okay, and then the period depends on highest value n, and then the block depends on last electron enter. Okay. Shazira, do you want to explain how do you get the period 3, group 13, and period 3? Period 3?
Saya rasa saya salah.
Salah kat
Orang
mana?
perasan.
Salah kat mana?
Kan dia last kali kan 3P1 kan?
Uh-huh.
So dia S block.
Like bagi tahu whether awak punya electronic configuration ialah apa. Kalau aluminium 13 kan. 1s2?
2S2.
Aha.
2PC.
Aha.
3S2.
Aha.
3P1.
Okay. Valence electron berapa? Valence electron ada berapa? Valence electronic configuration? Nampak dari sini tak? Mana satu ialah awak punya valence electronic configuration?
3s2, 3p1.
Okay. 3s2, 3p1. Madam repeat sekali lagi. Tak boleh ambil 3p saja. Kalau awak ambil 3p, nombor n dia sama. S dengan p kedua-dua adalah untuk level yang sama. So awak kena masukkan kedua-dua. Ingat dia belum masuk 3D, awak jangan fikirkan 4S 3D itu cerita lain. Kalau awak nampak value n dia sama, kita ambil sekali 3S dengan 3P. Okay, so when you circle it already, okay, so we take the numbers together, which is 3 valence electrons. So in this case, we got it correct. Okay, so the P block over here also you got it correct. Anyone can tell me why P block is correct for aluminium? Why is the P block is correct?
It's 2P1.
Because your last electron entering
P.
Untuk valence electron betul kita ambil semua, tapi untuk tentukan dia punya block, kita tengok pada last electron sahaja. Kita bukan tengok valence electron. Kita tengok electron yang last kali saja. So last electron entering P, so P block. And then the period also correct, which means the highest values of n in this case is n. So Shazila, actually you got the correct answer.
So madam, apa beza S block dengan P block?
Kalau S block, last electron entering S. Sekarang dekat sini, walaupun valence electron kita bulatkan semua, tapi yang last dekat P. Sebab kita ikut afpal kan. Afpal masukkan 3S baru 3P. dan seterusnya. So last electron dekat sini maksudnya elektron yang ke-13 masuk dekat 3p. So kita ikut yang last kali saja. Jangan tengok yang lain. Boleh?
Boleh, madam.
Okay. So is anyone want to ask the questions over here?
Ada.
Tak ada. Semua dah
Tak ada.
pandai.
Faham.
Irfan paling pandai.
Dah faham.
Madam,
Z3, ha? Ya.
if we write block P, get wrong or right?
Tak. Z3
Tulis
cakap apa?
balik. If saya tulis block P, betul kan?
Blok P betul. P blok betul. Asalkan nampak P. Asalkan dia awak punya SPDF betul. Blok P, P blok dua-dua boleh. Okay? Right. Okay. One more thing about here is the group. Since we have 3 valence electron and it's located in your block P. Ingat kalau block P, dia start daripada group 13 sampai group 18. So 3 valence electron, group 13. Boleh ya?
Boleh, madam.
Okay. Like Nabil, you want to explain about this one?
Okay.
Madam explain.
I will try. Okay. Kan kita ada 26 proton. So kita buatlah dulu satu S sampailah dapat 3D6. Lepas tu kita tengok dia punya valence electron. Valence electron dia 4S 2 3D6. So kita tambah dia punya atas tu dapatlah 8. So daripada situ kita tahu dia adalah group 8. Terusnya kita tengok the highest value of N 4. So kita dapat period 4.
Okay.
So kita tengok sebab dia punya block dia adalah block D.
Kenapa block D?
Sebab dia punya last 3D.
Last 3D. Last apa?
Last electron
Ya, last electron masuk dekat 3D. Jadi dia adalah datang daripada block D.
Yes,
okay. So block D is actually from your group 3 until group 12. So when you have 8 valence electron, you need to stop and think. 8 sama ada dia adalah kumpulan group 8 or group 18. Sebab group 8, group 18 dua-dua 8 valence electron. But you need to focus on the block. Where is the last electron entering? If it's block D, that means you only can choose within this range only. So block D, group 3 until group 12. So since you have 8 valence electron, therefore it comes from your group 8, which is in the range. Okay? So in this case, 8 valence electron, group 8, period 4, and block D. Any questions?
Teacher.
Ya.
Saya tak faham kenapa kira valence electron dia 8
Okay, kita ambil kedua-dua ni. 4S dengan 3D. Sebenarnya, valence electron biasanya kita ambil yang paling tinggi kan. Tapi sebab ni, 4S2 adalah yang paling tinggi. Okay, tapi untuk 3D dia belum penuh. Okay, kalau ada tambahan elektron, kita akan masuk dekat 3D dekat sini. So, bila awak nampak S dengan D, 4S 3D, 5S 4D dan seterusnya, kita akan ambil kedua-dua, 4S dengan 3D sekaligus. Sampailah awak nampak 4S 2, 3D 10, tapi dia belum masuk dekat level yang next lagi, kita masih lagi ambil ini sebagai dia punya valence electron. Irfan, you need to watch the video mentioned earlier. Untuk valence electron, siapa yang tak faham, tengok balik video tersebut. Sebab ini nak ulang balik sekali lagi untuk valence electron, cerita dia 10 minit. Tanpa NG bila madam record video tu banyak NG. That's why it take a little bit of time to resend your to send you the video. Bukan macam ni ada tak adalah dalam video need to cut a few times. Kalau tak percaya, awak record video next time.
Okay, so S dengan D je lah kita akan gabungkan dia.
Ya, tapi jangan ambil, kalau awak ada 3S, 3P, jangan awak ambil benda lain. Yang ini hanya untuk S dengan D. 4S, 3D. 5S, 4D. 6S, 5D. Ni saja kita ambil kedua-dua. Yang lain tak ada.
Okey, faham.
Alright. Ada soalan
Madam.
lain? Ya?
Jadi kiranya kalau kalau 4S1 terbalikkan je lah kan.
Kenapa 4S1?
Katakanlah kita buat yang arrangement tu kan. Kita dapat 4S1. Oh. Oh, jap, tu
Okay.
chromium.
Hazim, that one is for anomalous case.
Sorry,
Anomalous case. Sama juga kita ambil masuk, kita merangkumi 4S dengan 3D. We include both. Tak kisahlah dia anomalous ke yang normal. Okay.
Alright, noted.
Next one we have sulfur. Okay. So do you agree with the answer? Valence electron 6, group 16, period 3, and block P.
Yes.
Agree.
Agree, ya. Alright. So Syarius, okay, well done. Kalau untuk sesiapa yang tak Okay, kalau untuk sesiapa yang tak faham dekat sini, hold on. You need to redo the electronic configurations, whereby we have 1s2, 2s2, 2p6, 3s2, and 3p4. So in this case, take along 3s and 3p, 6 valence electron from group 16, period 3, the highest value of n, and then block P because last electron entering P block. Okay. So we go back into your exercises. For question number 1, okay, the one that Madam, actually you have to practice all of them lah to familiar yourself with the electronic configurations writing and also how to determine the valence electron, the block, the group, and the period. So untuk part yang Madam highlight, sebenarnya Madam nak awak cuba sekarang tapi tak apalah, nanti hantar dekat Google Classroom. Sekejap ya, Madam lukis dulu. Okay, so for 1, B, E, F, and K, this one that Madam want you to practice and handing into Google Classroom. Ada soalan lain? Nanti Madam summarisekan berapa yang Madam nak. Okay, we try one questions together over here. So this is a different pattern of answering of the questions lah. Okay, different pattern. So let's see over these questions. We having a table. So in this table shows you the group and the period of elements C, D, E, F, G. Okay, write the electronic configurations for each of the element. So how are we going to write it?
The highest N dia 2. Betul, Madam.
Okay, kita try satu persatu ya. Okay, period show you the highest value of N. So if you got period 2, that means N until 2. If you got N equals to 3, that means highest N value is 3. The group show you the valence electron. So from here, you need to know also your valence electronic configuration. Kita cuba yang C dulu. Okay, C over here, up until N equals to 2. So group 16, how many valence electron?
6.
6 valence electron. N value untuk ni adalah 2. So kita start lah 1s2, 2s2, 6 valence electron. Kalau 2s2, kita sambung 2p berapa?
2p4.
2p4. Okay. Ingat bila nak dapatkan valence electronic configurations, we take for 2s and also 2p. So 2p2, 2p4. All together give you 6 valence electron. Boleh?
Boleh, Madam.
Boleh, Madam.
Boleh, Madam.
How about D? N until 3. And group 14, how many valence electron?
4.
4 valence electron. So we have 1s2, 2s2, 2p6,
3s2,
3s2,
3p2.
3p4 ke 3p2?
3p2. Sorry, madam.
3p2. Sebab kedua-dua tambah sekali akan bagi awak 4 valence electron. So you need to recheck back. Takut ada masa kita silap kan. Check balik. Valence electron grup kumpulan 14, 4 valence electron. So 3s2, 3p2 tambah sekali dapat 4 valence electron. Everyone's good?
Good, good.
Yes, madam. Good.
Yes,
Okay.
madam.
Try about E.
1s2 sambung.
2s2,
2s2,
2s2, 2p6.
3s2,
3s2,
2
3p6,
3p6,
Uh-huh.
3d10,
4s2,
Ooh.
3d10,
4s2
4s2. Lagi?
3d10.
Ada lagi
Ada kan?
Ada.
Sebab highest 4.
Highest 4. Okay, highest and value 4. Berapa bilangan valence electron?
2
2. 2 valence electron. Kumpulan 12 dekat blok mana?
Oh, lah. Betul.
Transition.
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 So,
So
got
transition
D.
daripada group 3 sampai group 12. So sampai 3
D.
D
3d,
10.
10 pandai. Okay. So period 4. Okay. Group 12. Remember we only got one group 12. Group 12 is located inside your block D. That means your last electron need to enter D orbital. Okay. 12 valence electron, bukan 2. 12 valence electron in this case. So 1s2, 2s2, 2p6, 3s2, 3p6. Then entering 4s and 3d. So in this case, 12 valence electron come from our 4s and 3d.
I
If
see.
sebelum masuk 4p, 3d pun kita kira sekali sebagai valence electron. Once dia masuk 4p, 3d ni kita push dia masuk ke dalam inner shell. Okay.
Faham.
How about F?
Satu S2, 2 S2, 2 P6, 3 S2, 3 P6, 4 S2. Itu saja madam. Saya
Ada
yakin.
3 tidak?
Tak ada sebab
Tak
ada
ada.
group 2.
Sebab
group
dia
dua.
group 2. Group 2 blok mana?
Block S.
Block S. So that means your last electron should enter S orbital. So you stop at 4s only. So pay attention to E and also F. How about for G? G lagi complicated sebab dia sampai period yang lagi tinggi. G, 1s2, 2s2, 2p6.
3s2,
3s2,
3p6, 4s2, 3d10, 3d10, 5s2,
4
P6,
2p6,
and
5s2.
5s2.
4
Dekat
D10.
sini kalau awak tak boleh hafalkan, boleh tengok balik awak punya raindrop diagram. 4s, 3d, 4p and then 5s. Okay, so in this case, the highest n value is 5. And then the last electron entering your S orbital, which refer to your S block. And then you have only 2 valence electron, therefore it comes from group 2. Boleh ya?
Boleh, madam.
Okay. So the questions B over here, write the electronic configurations for the most stable ion for C, F, and G. C, F, and G. So for C, what is the ion that you're going to form?
C negative 2.
2 minus.
C2 minus. Okay, that means you are accepting the electron, then the electronic configuration will until 2s2, 2p6. How about F?
F2 plus.
Why F2 plus?
Remove.
Remove the
two
2
electron.
electron. So awak punya electronic configuration sampai 3p6 sahaja. So electronic configuration nanti awak tulis sendiri. Okay. How about G? What is the ion that you're going to form?
G2 plus.
G2 plus. Dia lebih kurang sama macam F lah. Sebab dia punya valence electron adalah sama. Okay. And then for C, it asks to write the electronic configurations for E2 plus. Okay. So tengok pada E dekat sini. Okay. We got 4s2 3d10. In order to remove 2 electrons to form the E2 positive, where should you remove the electron first?
4s2.
4s.
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 So awak akan keluarkan 2 elektron daripada 4s. So awak punya electronic configuration tinggal tinggal 3p6, 3d10 sahaja tanpa 4s2. Okay, so remember removing the electron from 4s before 3d. So any question for this? Question number 2. Is everyone all right?
Okay.
Yes, madam. All right.
We're
Yes,
all
teacher.
right.
Right. So, cuba lagi soalan soalan 3. Consider the electronic configurations for the following element. We got PQRS. Determine the number of valence electron, the block, the group, the period. Nah, nampak cara dia tanya lain. Tadi kita bagi proton number, awak kena keluarkan electronic configuration. Yang ini terus. So tell me about for P. What is the valence electron?
6.
6.
Okay, for P valence electron, we have 6. How about the block? Kita ikutlah soalan.
P.
P. How about the group?
16.
16. How about the period?
3.
3.
3. Kita check ya. Untuk P, this is your valence electronic configuration. So 6 valence electron. Block P, yes, the last electron entering P. Group 16 because it's in P block. And then period 3 because the highest value N equals to 3. Well done. How about Q? Valence electron?
1.
1.
Block?
S.
Group?
1.
1.
Period?
1. Period.
4.
4.
Okay, for R, how many valence electron?
3.
3.
3 because it including 4s2, 3d1. So 3 valence electron. What is the group?
D.
Group D.
Group 3. Group 3. Block D.
Block.
Group D.
Block D.
Okay, untuk R ya, kita punya valence electron ada 3. Okay, how about the block?
D.
D. Sebab last electron masuk dekat D. How about the group?
3.
Group 3 sebab dia block D. Starting 3 sampai 12 sahaja. How about period?
4.
4. Okay. Sebab highest value 4. Okay. How about the last one? Valence electron berapa? Nah, ini challenging a little bit.
7.
5.
5?
5.
5. Because 3.
Okay.
I think it's 7, isn't it?
7.
Ada lagi N yang tinggi sama dengan 4 tak?
Oh.
S2.
Selain 4P, ada lagi subshell lain dengan N sama dengan 4 tak?
4S2.
4S2 kan?
Yeah.
So ini kenapa madam cakap kalau awak yang tulis electronic configuration kan, 3D nanti awak pindah masuk. So that you won't left out this 4S2. So you need to recognize to always check back. Kalau dia sudah sampai period yang keempat, awak kena hati-hati. Dia punya valence electron 4s dengan 4p. Okay, so in this case for your S element, the valence electron all together we have 7. Ini ialah soalan apa ni? Kesalahan yang selalu budak akan buat budak. Pelajar akan buat. You akan buat. Akan tersilap anggap hanya ada 5 valence electron saja. Okay, so you need to pay attention for S as well. Okay, so for S2, for P5. How about the block?
Block
P.
Block P. How about the group?
17.
17. Well done. And the period will be?
4.
4.
Okay, very good. All right. Question number 4 also kind of similar. That means you need to write the electronic configurations. You need to identify valence electrons, that the group, the block, and the period. Okay, so for questions number 4 also need to submit inside your Google Classroom. So yang tadi berapa soalan nombor 1 B, E, F, K. Tempat yang ada highlight purple Okay, dengan soalan 4. Submit dalam Google Classroom. Everything alright?
Okay. Alright, madam.
Madam nak check sama ada you pay attention tak? Okay, kita akan buat quizy Okay, I know what I did wrong for the last lesson where we have the VIP. Madam tertekan classic. So masa yang awak buat in individual. But Madam prefer to do it together. Can we do it together?
Boleh
Yes,
je dia.
madam.
Yes.
Boleh ya? There's 8 questions altogether. And you can enter the game code 244857. So I want to see whether you have already understand and able to apply for chapter 3.1. Chapter 3.2 will be totally different from 3.1. 3.2 is more towards concept, theory, and short essay. Right, keep on joining. 64. I have 99 students altogether with 3 absent. Siapa yang absent ialah siapa yang sudah bagi tahu madam yang penting tak ada dalam list. Madam akan tulis penting saja. Hmm, 17. Another 29 to go. Siapa Mai? Mai satu ke Mai Sarah? 72. 73. Irfan handsome. Ini Irfan mana? Madam ada 2 Irfan. Zarif Irfan ataupun Irfan Farhan
Nabil Irfan.
Irfan Farhan. Jamie
Hi.
Nijami. Madam dah mula catch up your punya name Jamie ialah Nijami. Nijami chapter tu kena practice banyak sikit
Madam, can I see the code?
Sorry. 244857.
Madam, I have one question.
Ya.
Kita ada pre-UPS tak?
Pre-UPS? Link yang hari tu Madam hantar. Itu
Hey, you
adalah
already
Yes.
Can you resend the link, please?
You tak baca Telegram. Madam ada hantar lah sayang. You tengok
No,
dekat
actually,
sini.
I have a bad memory.
Dekat mana Dia sudah ada deadline sebab pre-UPS is for how to say under units one. Now you see. Good morning all. Test run UPS is your pre-UPS actually. So everyone please kindly check your name. Tak ada orang spelling error Tak ada orang yang bagi tahu nama salah, so madam assume semua okey lah. Okay, lepas tu you may try anytime before 3 of September. Now it's already 5th, so for the link cannot access anymore lah.
Oh, this
Apa,
one.
boleh,
Already done.
boleh cubalah, tapi madam rasanya tak boleh access dah.
Already done. I thought the other one.
Okay, so let's just start ya. 89.
Medium, saya salah tekan medium.
Saya pun sama.
Medium, mute medium.
Madam, are you using the mic right now?
Okay, can you listen to me now?
Yes,
Yes,
madam.
we can
Okay.
hear you now.
Right, so element was arranged in the increasing proton number. Another name for proton number.
What does it call? Nuclear.
Atomic number.
Nuclear charge?
Atomic number. Nuclear charge.
Okay, or nuclear charge. Well done. Okay, so those were atomic number. Over here, what is the questions? Full questions. Will atomic number. Okay, so we prefer the atomic number. Atomic number is your nuclear number. Sorry, a little bit correction. Proton number is atomic mass. Okay, atomic mass. The first one madam do is correct lah. Proton number is atomic mass. Okay, so for those who choosing row 1, sorry, corrections over here. Okay, so we choose the increasing proton number. All right. Next questions. All right, so for question number 2, it's also quite easy. Well done, Chloe. Alwin, Hazwani. Okay. In the modern periodic table, the period indicate the values of the principal quantum number. Okay, which is your values of n. Ramai juga yang pilih atomic number dengan atomic mass ya. Okay, period period kita ikut value n. Okay, value n. Nah, tadi awak isi kan, what is the highest value of n, and then that one will refer to the period. Okay? Next questions. All right. So most of you got it correct. Well done. So which is the following is the outermost shell for element of period 2. So when n equals to 2, that is your outermost. Okay, outermost, which actually means the shell which is located at the very outside. Okay. Next questions. Change a little bit in the leaderboard. Okay, so most of you got it correct. Ada yang juga pilih number of inner electron dengan proton element from the same group, usually they will have the same number of valence electron, or sometimes we would say similar chemical properties. So number of electrons refer to your chemical properties. And next questions. All right, so what element is this?
Transition.
Transitions element. Siapa yang pergi pilih alkali earth method? Alkali earth method, which group? Anyone know?
One.
Group 2.
Group 2. Group 1 is called as alkali metal. Group 2 kita panggil alkali earth metal. Noble guess?
Group IP.
Group 18. Okay, next questions.
Zim boleh mute tak?
Sorry.
Well done. Yes, most of you got it correct. So let's see the full questions. Yeah, S has an electronic configuration 1s2, 2s2, 2p6, 3s2, 3p4. Okay, so it goes to the third answer. Yeah, group 16, period 3, and p block. Okay, so 78 of you got it correct. Very well done. And the next questions, also given 45 seconds. Right, we change a little bit in the leaderboard. Okay, so for this one, we have two major answer. 71, most of you got it correct. And then there's another 14% choose the first answer. So let's see. 4s23d6, what is the correct position? So the highest values n give you the period 4. Okay, the total valence electron we got 8. So it will be in group 8. Okay, and then the last electron entering D will be in D block. So between the question, the answer 1 and the third answer is group 18 or group 8. So remember over here, D block is starting from group 3 until group 12 only. Okay, therefore, when you have 8 valence electron, automatically you will fall into group 8. Okay, so for those who mixed up, you need to understand this concept, yeah? And we have our last questions. Another 50 more seconds. Right, congratulations to those who are listed over here, and well done, most of you got it correct. So group 18, that means there is 8 valent electrons. So 1s2, 2s2, 2p6. Okay, taking the 2s and 2p subshell together, we have 8 valence electron. And highest value of n give you 2, therefore it comes from period 2. Okay, so far anyone have any questions regarding to chapter 3.1?
No.
Ada soalannya. Okay, Madam nak tahu untuk awak bila Madam mainkan quizzy, you dengar suara tak?
Dengar.
Dengar, ya. Okay, so well done. We have Alvin, Tasik, and Rifi. First, second, and the third. And most of you got 100% correct. And class accuracy, we got 79%. Okay. So this one, Madam will record as your, what do you call it? The attendance now over here. Those who cannot access the quizzy, please let Madam know. All right. Okay, so back to our Google, OneNote. So what are you going to hand in Google Classroom? Google Classroom kena hantar apa ya? Yes?
This homework.
Ya, homework. Kita ada soalan 1, ada 4 dengan soalan 4 dekat sini. Okay, another 20 minutes. Let's see whether we got enough time or not. Okay, we can touch a little bit of chapter 3.2 as a preparations for our Tuesday class. Okay, for today's Tuesday class, later Madam will enter about some explanation. So topic 3.2 is more towards explanation and description. Okay, and then most towards the theory. So dia banyak kena tulis short essay. When Madam talk about short essay, it's not like writing a real essay, bukan buat karangan. Awak masih boleh keluarkan point, okay, tapi dia agak panjang sikit untuk jawab satu soalan. Okay, dan soalan-soalan ini akan keluar dalam awak punya assignment juga. Okay, so let's look a little bit, another 15 minutes like that. We just talk about this one, right? So for chapter 3.2, here is your learning outcome. It's slightly longer than 3.1 and it's totally different. Kita tak ada mention lagi electronic configurations, the period, the group, the valence electron and so on. But you need to recognize the terms. For example, period, the group, the transitions element, size, radius. So let's see the learning outcome. For A, describe variations of atomic radii. Radii with 2i over here is a plural form of radius. Okay, it's the same thing when we talk about atomic size. So bila madam cakap atomic size, atomic radii, atomic radius, that means the same thing. So you need to be able to explain across a period. Okay, for transition element, for the first row only, you need to explain the atomic size or atomic radii down a group. And then after that, you need to analyze the variations for these three category. What is the trend? Is it increases, decreases, or remains the same? And then for C, compare the atomic radius of an element and its corresponding ionic radius. And then after that, we need to define. So this is a whole new term for you, isoelectronic. Something to do with the electronic configurations that you have learned before. But what it means by iso, you need to define. For E, compare the radius of ion electronic species. Analyze variation in ionic radius across period 2 and period 3. Define the first, second ionization's energy. Analyze variations in the first ionization energy across a period and down a group. It's more toward description. Then you need to explain why the ionization's energy increases. And then deduce the electronic configurations of an element and its position in the periodic table based on successive ionization energy. K, define electronegativity. Explain the variations of electronegativity. And last one, explain the acid-base character of oxide in period 3. So for all over the learning outcome over here, madam just want to touch about two of these things. Okay, some new terms to you. So atomic size, we want to explain the trend. When you talk about the trend, is it increasing order, decreasing order, or the size remains the same? So we need to describe three of this category. First one, across a period, down the group, and among the transitions element for first row only inside your periodic table. So what factors are going to affect your atomic size? So dekat sini you boleh catat juga size. We can also describe it as radii, or plural form, or singular form, we call it a radius. Okay, so factors affecting atomic size divide into two. We have effective nuclear charge with the symbol Z, capital letter, and then we have EFF at the bottom. So normally we call this one as Z effective, okay, or call it as ZEF. So it means the effective nuclear charge. So if you remember just now, we said Z, it can refer to proton number. Okay, it can refer to nuclear charge, or just now, madam do a correction, atomic mass. So nuclear charge, atomic mass, or proton number of proton. So it refers to the symbol Z. Okay, and then the second factors over here, we have the shielding effect or screening effect. So look at the red box over here, madam give a little bit of definition. For effective nuclear charge, our Z, okay, our Jeff, is the net positive charge experienced by the valence electron. Okay, so let's look at this video. Can you listen to the sound?
To find the
Dengar tak?
effective nuclear charge of an atom or ion, two variables are important. These
Can you listen?
Yes, madam.
Right.
variables are Z, the nuclear charge or number of protons, and sigma, which is the screening constant. We use these two variables in the following formula in order to calculate the effective nuclear charge, Z effective. Z is easy to find because it's simply the atomic number of the element. For example, carbon has a Z of 6, nitrogen has a Z of 7, oxygen has a Z of 8, and fluorine has a Z of 9. To find sigma, we have to count the electrons found in layers that have a lower principal quantum number than the valence orbital. To do so, we need to look at the electronic configuration of the element in question. For example, let's look at the effective nuclear charge of the valence electrons in sulfur. We'll start with its electronic configuration. 1s2, 2s2, 2p6, 3s2, 3p4. Sulfur has a nuclear charge of 16. The principal quantum number of its valence orbital, 3p4, is 3. To find sigma, we count all the electrons with a quantum number of 1 or 2. Be careful not to count the 3s2 electrons. Even though they have a lower energy level than the valence electrons, they share the same principal quantum number. We end up getting a sigma of 10. If we subtract this value from our Z value, we get an effective nuclear charge of positive 6. Here's how.
Okay, so if we take this example, you have two terms that you need to recognize. First of all is the Z, okay, which in this case we call it the nuclear charge, and also the ZEF, which is the effective nuclear charge. So this is the electronic configurations that we have learned before. Inside the inner shell is your inner electron, or we call it as the core electrons. And then over here, 3s2, 3p4 is the valence electron. Okay, so in order to know what is your ZEF, you need to use this nuclear charge minus the inner electron. This is a symbol, okay, a sigma symbol which represent your inner electron or the core electron. So 16 minus 10 inner electron, and the effective nuclear charge over here give you positive 6. That means the outer electron, your valence electron, this 6 electron, will experience only the power of 6. Something like how much is the power forces of attractions from the nucleus. Okay, so instead of 16, okay, 16 is the proton number, you only experience positive 6 from the nucleus. Okay, so forces of attractions between the valence electron and the nucleus. That is what we call as the effective nuclear charge. So we back to the notes over here. Again, effective nuclear charge is the net positive charge experienced by the valence electron. Therefore, when we say if you got higher nuclear charge, you will have higher ZEF, okay, higher effective nuclear charge. So the stronger is the attractions, therefore you will have a smaller size. So can you imagine that when the nucleus is getting stronger and stronger, it's like a magnet to attract the valence electron. So now this power increases, okay, and you manage to pull in the outer electron stronger. Therefore, the size will getting smaller. It's about it's strength enough for the size. So in this case, this is short notes for you to understand about the ZEF. So is there any questions about the ZEC and the ZEF? Nuclear charge and also the effective nuclear charge.
No, madam.
Okay, yeah. So this is one of the terms because we will keep on mentioning about the Z effective. Okay, for the whole 3.2 over here, we will keep on mentioning the Z and the ZEF. So you need to understand between the differences between the nuclear charge and also the effective nuclear charge. Okay, the next term that you need to understand is the shielding effect, or also called as the screening effect. Shield or screen, dia macam satu halangan. Okay, so the definitions in this case we will define as the ability of inner electron, okay, to reduce the nucleus attractions towards your outermost electron. So let's see the videos over here. There's another short videos for you.
Moving down group 1 of the periodic table, atomic radius increases by 1 electron shell. Lithium has 2 electron shells. Sodium has 3 electron shells. Potassium has 4 electron shells. We know that these alkali metals can lose their lone electron in their valence or outermost shell to form an ion with a positive 1 charge. In fact, this is what happens when an alkali metal reacts with water. The ease of formation of the ion is directly proportional to the ease of losing that electron. Moving down the group, the outer shell electron becomes further from the nucleus. This decreases its attraction. Shielding is defined as the decreased electrostatic attraction between the nucleus and the outermost electrons due to the presence of additional electron shells. Shielding increases. This again decreases the attraction for the outer shell electron. Although nuclear charge increases, the atomic radius and shielding, as mentioned, outweigh this increase. So moving down the group, it is easier to lose the outer shell electron. We can think of the nucleus like a magnet. A magnet is able to hold onto an iron nail. Wrap the magnet with a sheet of cloth, and it would not hold onto that nail as effectively. Wrap it with another sheet of cloth, and it would be even harder for it to hold on to that nail. The same idea applies to the alkali metals. If there are more electron shells present between the nucleus and the valence electron, the attractive force of the nucleus to that electron will be weaker. So the greater the shielding, the easier it is to lose an electron to form an ion.
Okay. So in this case, when we talk about the shielding effect, so you need to imagine, and this one is based on your imagination. So let's say we focus on the group 1 elements. Okay, this is the nucleus. Okay, and then you have the outer shell. So starting from lithium, you know that you only have 2 shells. So that means you only got 1 shell as the inner shell. Okay, and then when you move into sodium, you have 2 inner shell. Okay, and then those electrons sitting in the inner shell is your inner electron. So this shielding effect is like shield. Siapa boleh tolong translate what it means by shield? Ada tak siapa boleh tolong translate kan? When you go into the war, right? The soldier is holding the shield. Penghalang kita panggil. Okay, so the inner shell over here, or your inner electron, is behave like a shell that is decreasing your forces of attractions between the nucleus and your outer electrons in this case. Okay, so the video or the link Madam can share it to you afterwards for you to watch the whole video, but you need to grab the concept. What it means by shielding effect. So antara Madam dengan awak sekarang ni, kalau kita dekat kelas kan, okay, the first students, you will have less shielding effect because it's directly interact. Okay, but the students that are sitting at the back of the class, that means in between there's so many students that screening or shielding the interaction. So biasanya you all suka sangat duduk kat belakang kan, sebab dekat tengah-tengah banyak pelajar yang lain. Awak punya kawan yang lain dekat tengah. Okay, so this is the analogy of when we describing about the shielding effect. So we look at the definitions again. Ability of the inner electron to reduce the nuclear attractions towards your outermost electron or the valence electron. So more inner electron, you will have higher or greater shielding effect. Therefore, forces of attraction will decrease. Okay, and then the size will become bigger. So the further explanation, we will look into each of these category across a period, down the group, or among the transitions elements. So is there any questions about the ZEF and also screening effect? Yeah, class?
No, we don't.
Okay. So I will only explain up until this part, and then you can rewatch the video again a little bit later at your own time. And then for Tuesday class, Madam will start from the atomic size, and then we'll see whether we can finish until isoelectronics terms or not. Okay, so I want you to prepare also for the notes starting from atomic size. For chapter 3.2, most of the, if you look at the notes that Madam given, because this one is assignment-based chapter, so most of the questions Madam have already provided the sample answer, but you just fill in the blank. So we can save a little bit of time by doing the exercise together. Okay, so I want you to look through first, and then we'll discuss again for the next lesson. So is there any questions before we end the class for today? Ada soalan ke?
No, madam.
No, madam.
Okay. So if no questions, then Madam will end the class for today. And don't forget to submit your homework into Google Classroom.
Okay.
All right. Thank you, class.
Thank
Thank you, madam. Thank you, madam.
Thank you, madam.
Thank you,
Thank you,
madam.
madam.
Thank you, madam.
Thank you, madam.
Thank you, madam. Thank you, madam. Thank you, madam. Thank you, madam.